Let's turn our attention to the very important topic of revision control. Basically, revision control is keeping track of what's currently in some set of files. And that is, in our context, going to typically be a set of files that contain computer code, but we could also keep track of revisions of documentation, of plans, of specifications, of basically any kind of computer document or file that we would like, we can keep track of in revision control. And we're going to look at revision control sort of generically, but in particular, we're going to look at using the Git system for revision control. So by way of introduction, here's just a definition. So a version is just the snapshot of the current contents of a file or multiple files. Again, to the idea of using version control for software development, it's basically just the contents of the source files that make up your project at any given point in time. Another common word that's used in this context is revision, and revision and version we're just going to use as synonymous here. Different systems have used different terminology. I kind of like revision because it seems to be relatively specific to this idea of the current contents of your files, where version gets used in a lot of other places, like the version of the software or the release version or the beta version and those sorts of things. So revision, I'll try to use that consistently to refer to the current contents of your files, but I'll probably slip and use the other term as well. Then given that information, we have the notion of a revision control system. So this is a system that stores and retrieves revisions, as you might guess. Nothing super complex here. And the particular revision control system that we're going to ultimately focus on is a system called Git. So that's a software system that allows us to easily keep track of revisions of files. Why do we care? Why do we use revision control? One key reason is that it makes it really difficult to lose any of your work. We've all had the experience, I think, over time of accidentally deleting a file or overwriting a part of a file with a copy-paste command or something like that. And if we're using revision control, we have kind of the history of all those files that we're working with. So the amount of information that we can lose at any one time is really only the changes that we might have made since the last time we put something in the revision control system. We can always get back to that. And if you do those updates to the revision control fairly regularly, you're not going to be losing a whole lot of work if you accidentally do something dumb, because we all do it. A second reason to use revision control is it makes it easy for us to see what's changed over time. If we're working on a particular piece of software and we want to know what did this particular function or this particular program look like yesterday, or 2 months ago, or 2 years ago, or maybe more interestingly, the last time we released it to the public users, we can use revision control to compare the version from that previous point in the history of the file to the current version. That can be super helpful when you're trying to fix defects, when you're trying to understand work that someone else did that maybe left your organization or something like that. So you can see what's changed. It's also useful for thinking about your own work. You can look and see what did you do in the last few days, because sometimes, you sort of forget those sorts of things. Revision control, because it allows us to keep track of things over time, lets us answer sort of hard questions that are difficult to come to conclusions on if we don't have this history of a project. One of these is, why doesn't this work any longer? If I'm working on a piece of software that I'm pretty sure worked yesterday and now it doesn't work, one way to try to diagnose the reason is to go and look at what's changed since yesterday's version. An even harder question to answer sometimes is, how could this ever have worked? You're looking at a piece of code and it's not working and you think, wow, this is just fundamentally broken. But you realize that, hey, in the past it has worked, and how is it possible that that was true before? Again, you can look in the history of the project, you can compare the current version to previous versions, and usually that gives you quite a lot of insight into answering these kinds of questions. And a final reason that I'll highlight right now is that it makes it easy to collaborate with other people. If you're working on a team, which is pretty much what you're going to spend the rest of your career doing, you've got to be able to share your work with the work of others. And you don't want to have to sort of wait for everybody else to get done with their thing before you start working on yours. So the interactions back and forth between other members of your team as it relates to, say, the code that you're creating can be quite complex. And a revision control system that's worth its salt is going to give you the capability to share that information back and forth in such a way that everybody stays productive, that everybody can still work on the system at any given time, and that allows you to move information back and forth between different developers without, again, losing any work, with the ability to understand what's changed since the last time you took work product from another person on your team, and with the ability for you to make your work available to others on the team at a time when they're ready to consume those things that you've added. So very important to be able to share work. And then also it keeps you from stepping on each other's toes, because you can share your work product in a way that others can retrieve and integrate into their code at their convenience. It's very unlikely that you're going to do things that are going to cause other people to lose code and those sorts of things. We're going to explore some of those possibilities here in a moment, but that's kind of the high-level view of why we care about using revision control. I think it's always helpful to take a look at kind of the history of some of these technologies. So I want to start by describing what the world was like for software development in what I'll just call the bad old days. So here's an example of a type of revision control. I've called this individual revision control, but it's basically just a nightmare of different weird names. So you can see here in this little tree diagram, I've tried to give you some sense of a home directory, right? So here's a source directory that's got a library in it and then some source files in a C program. And you can see if you look at these files, well, there's a main.c. That seems like a, real source file, but then there's these other weird things like main.c.1 and main.c.2 and main.c.4, which kind of look like maybe they're previous versions of main.c that I thought maybe I should keep around just in case I have to go back and figure out what I was doing 1, 2, or 4 revisions ago. Not quite sure what happened to main.c.3, so that's a mystery. Or you can see things like main.c.broken, or eventually this sort of drives you to despondency. So main.c.sucks, main.c.yesterday, but well, what's today relative to yesterday? And the same sorts of things are here in the source file for this library. Different numbers, different backup, a test version, one from Tuesday, and then presumably the one that we're working on right now. Now this is a time-honored tradition to be able to keep track of old versions of files by just copying them into a file with another name. But even for this relatively modest number of source files, you can see that it's not quite clear what's changed, what's different, when these different revisions were created. I suppose you could get the date from the file system, but it's still just not a particularly effective or systematic way of keeping track of work. So although we still do this kind of stuff, it's not a particularly effective way to keep track of revisions. And the other problem with this is it's individual. It's not going to help you share work with other people. In fact, if you stumbled across somebody's work product and it had this kind of a structure to it, you might think, well, I don't want to monkey with this because this code base is obviously really goofed up. Let's think about some ways that we can collaborate in terms of revision control. So this is a tennis shoe. One of the ways before the wide availability of local area networks and the internet of sharing information back and forth between developers would be to use something called a floppy disk. You may have seen or heard of these things. Little rotating storage inside of a Mylar envelope. And so what you would do basically is take your source code, store it from your hard disk on your development machine onto a floppy, and then put on your Converse All-Stars and literally walk it to somebody else's computer where they would take that floppy, put it in their computer, and do the reverse, copy stuff off of that floppy onto their machine. So this method of sharing files was referred to as sneaker net because you were networking with your sneakers on. Now this has quite a lot of drawbacks to it, not least of which is that if both of the developers involved in this are working on the same source code, let's say that they both happen to change the contents of the same file on their individual workstations, and then one of them copies his files onto the sneakernet disk, walks it over to the other developer, and he or she puts it in the machine and copies across from the floppy. Now they've lost all of the work that they've done on that file that was also modified by the first developer. So it's collaboration, it's a time-honored tradition, but probably not a particularly effective way to do mission-critical development work. Now, as soon as we had real networking and shared drives and that kind of stuff, we kind of evolved into something else that used the network now, still a collaborative thing, so all developers can talk to the same network shares. But all that we're really doing is providing kind of a convenient infrastructure to do the same kind of horrible things that we did back here in the SneakerNet days. So 2 developers are working in their individual work areas. And again, you could have the situation where they both make the change to the same file, and then when they want to share their results with each other, the first one copies his source file to the shared directory, and then the second one copies his work files to the same directory and overwrites the first changes. So we've pretty much just lost information again, although in that case the first developer still probably has a copy in a local directory, so that's not so terrible. But the possibility of overwriting things is there. There's no information about the history of the project. You can't go back and ask what's changed between one version and the next, because you just have these files that everybody's clobbering in a shared directory. So hitting the OK button here in this dialog box can be pretty disastrous. The next generation of revision control systems is usually called centralized revision control, and that's a key idea here that we'll unpack in a second. First, let me introduce you to 2 developers, Alice and Bob. If you haven't encountered these before in a class or in some reading someplace, be aware that Alice and Bob are kind of the prototypical developers or participants in any sort of a computer science discussion. If you don't have other names to give people, call them Alice and Bob. It's not coincidence that the first 2, the letters of those names start with A and B, and you'll see other characters that appear in different kinds of literature and so forth. But Alice and Bob we'll just use as our prototypical examples of developers. Now, what I've got in this illustration is that Alice has what we call a sandbox. That's kind of an informal term that might be more officially called the development directory or working directory or something like that. Basically, the idea is Alice has a directory someplace in the network that she owns, that only she can make changes to. That's the principal place where she's doing development on some project. So all of her source files and other data files and so forth are stored in this sandbox directory. And it might have a bunch of subdirectories and other structure. But at some point you could say that's Alice's directory for working on this project. Similarly, Bob also has a sandbox, which is probably, since we're assuming that Alice and Bob here are working on the same project, his sandbox is probably really similar looking to Alice's, and they can continue to work independently of one another on that same project, making changes to whatever files that they would like to change without influencing one another's work. In order for them to communicate with one another in ways that don't have the same deficiencies of the systems that we've just described, we're going to introduce a third piece here that I've called the central repo or the central repository. The idea of a centralized revision control system is that there is such a central place where the kind of official copies of all of the source files that make up this project are stored. So, for example, when Alice is ready to share her work product with Bob, the changes that she's made in her files, what she'll do is run an operation in the revision control system that's usually called a check-in. And a check-in is going to move files from Alice's sandbox into that central repository. Now, at some later time, when he's ready to do so, Bob could consume those files that have been changed by Alice by doing the converse operation from the central repository into his sandbox, and as you might guess, that's usually called a checkout. At least these were the terms that were used in the centralized revision control era. Now, the way that the central repo is designed is it's now smarter than just writing to a shared directory. So it's designed in such a way that Alice's check-in is not going to overwrite any existing files in the central repository. It's going to keep track of previous versions of those same files at the same time. And then when Bob is ready to check things out, that checkout command is going to be set up in such a way that it's going to try to avoid clobbering files in Bob's sandbox that Alice might have changed, but that Bob also might have changed since the last time he retrieved files from the central repository. So the check-in and checkout commands are smarter in this case than just doing a simple file copy or dragging a file into a directory in a graphical interface. they're going to enforce, those two commands are going to enforce some constraints that are going to allow Alice and Bob to collaborate without clobbering each other. Let's take a moment to kind of analyze pros and cons here of this type of a system. The clear pro is it's fairly simple. When you're thinking about this repository, there is exactly one central repository that everybody uses, and that's it. So the architecture is quite easy to understand and conceptually easy to use. There's some problems with it, though. The first of these is the question of locking. Now, in some of the early revision control systems, the goal was to prevent any possibility of one developer's changes overriding those of another developer. Now, as long as everybody is just checking things out of the repository, right, if the flow of information is always from the repository to somebody's sandbox, wherever that is, there's no possibility in that case for overwriting changes in the repository. The problem arises when you're trying to go the other direction, when you're trying to check something into the central repository. Again, related to the problem with the shared directory, if both Alice and Bob have copies of some source file and they make different changes to those files, and then Alice, say, checks hers in first and then Bob checks his in, the potential seems to be there that Bob's changes could overwrite Alice's changes, and so we would lose Alice's work. The early revision control systems had a kind of a ham-fisted way of trying to solve that problem. Basically said that we're only going to ever let one person access a file that can be changed and then checked into the repository. So under normal circumstances, if you just checked out files without any other special operations or options, you would pretty much get read-only copies of those files. So your local file system would actually have the files marked as unwritable, which you could change, I guess, if you wanted to, but that was sort of violating the rules. But the upshot of that is that you can't make changes to them. Instead, if you wanted to make changes to a file, you had to check the file out and tell the revision control system to lock it for you. That would check the file out into your directory, your sandbox, with writable permissions, so you could actually go in and make changes in your editor. But it would also leave a trail on the repository that says, hey, one person currently has this file locked. So if Alice went and checked a file out for writing, it would set that lock. It would let her write the file, make changes to it. But if Bob also wanted to make changes to it, he could try to check the same file out with the lock turned on, but the revision control system would deny him that option and probably let him know that Alice already has it locked, so he can go find Alice and they can kind of negotiate who's going to have access to that file at any given time. Now that did solve the problem, right? Because only one person at a time could hold the file for writing or for changes. And then when they were done making their changes, they could check their changes back in, and that would unlock the file so that if another developer wanted to grab that file and make changes to it, he or she could do that. So the problem seems to be solved. We're not going to allow overwriting any longer. However, now we're saying only one developer at a time can make changes to the same file, which is going to be an issue if you have, say, 100 developers working on a project. And the other thing is, if one developer is holding that lock on a file and then they leave for the day and you can't find them anymore, or they go on vacation for 2 weeks, they leave that file locked. Now nobody else can go and work on that file. Of course, the system administrator can still go in there and sort of manually unlock things, but it's just painful because it's easy for that file to end up locked inadvertently or for longer than intended. Another issue associated with centralized revision control is that of merging. And this isn't really so much an artifact of using a centralized system. It really has more to do with how revisions were saved in the system at this point in the evolution of revision control. The merging problem is, how do you take two different versions of a piece of software that might have changes that are made by two different people and merge them together so that you have one consistent set of files that include the updates that were made by both people without clobbering the updates of the other. Now, a simple case that's easy to deal with this problem is if the two different developers make changes to completely separate files and leave the corresponding files from the other developer's changes alone. Now it's easy to merge those two different versions together because the changes don't overlap each other. It's a little bit more complex if we've got a situation where two different developers make changes to the same files. In some instances, those are going to be easy to merge. For example, if we have a file that has 5 functions in it and developer A changes the first one only and developer B changes the last one only, it should be possible for us to go in and say, hey, let's just keep the changes from developer A for this part of the file and from developer B for that part of the file and merge those together to come up with the final version of that file that includes both people's changes. It gets more dicey if two different developers have made changes to the same parts of the same file, and merging those changes together now becomes rather difficult. In particular, the revision control system can't do that merge automatically. It's just going to say, hey, there's been mutually incompatible changes made to this source file. You, Mr. Developer or Ms. Developer, are going to have to resolve that yourselves because I don't know how to do it. So somebody's got to go in there and manually make those determinations of which revision of the same parts of the same file are going to survive into the final version and which are spurious or which are old versions or whatever that aren't going to make it into the final revision. This is further complicated, and this is where we get into the issue of how the revisions are stored. It's further complicated if there's a bunch of files that have those kinds of conflicting changes. And we'll see when we start talking about the distributed revision control system, how those systems deal with that and make that a lot simpler to do and a lot more reliable. Another issue with the centralized case is that there's a single point of failure. Since there is just kind of that one true centralized revision control system, all of the versions of the files that are part of a project are going to be stored on the same server, maybe on the same disk, in the same server room. And if there's a problem with that server, or the power goes off in that server room, or the disk crashes or something like that, you're now going to be unable to do anything with the revision control system across your entire team until that server comes back up. So that can be a problem if you've got particularly a large number of developers that are all relying on that centralized system. If it goes down, you're stuck. Another thing is that you're heavily reliant on the centralized revision control system whenever you want to do anything related to keeping track of revisions of your code. When you check something out, as we illustrated here in the previous slide, when you do that checkout, you're just getting the latest and greatest copy of all those files. Remember that the revision control system is keeping kind of a history of these changes that you make over time. But when you do a checkout, all you get from these systems is the latest version of all the files. Now that's normally fine, but if you want to go back in history and say, look to see what's changed between two different revisions, you're going to have to go back to the revision control system and ask it for some additional information about previous versions of that file, which means you're going to be able to connect back to the revision control system. Now, again, in many cases, that's not a problem. But let's say that Alice is going to work in a remote location at her company, and that remote location does not have network access to her centralized repository. She might check files out before she departs, but when she's at that remote location, without access to that centralized repo, she really can't check in changes. She can't do comparisons to see what's changed and that sort of stuff. So she's kind of hamstrung by the lack of connectivity. Or, for example, if she wants to work on a project while she's on the plane flying to that other location, because she won't be on the network, she won't have access to that repository. And that, although it's not a huge problem, is definitely an issue with the centralized systems. Here's a list of some of the common systems that were built on this model. The source code control system came from early Unix releases, the System 5 Unix. Then an open source revision control system followed that, and they just called theirs the revision control system. Kind of a step forward from SCCS, less clunky, more granular commands. Still the check-in, check-out idea very prominent. The RCS actually had a couple of programs called CI and CO for check-in and check-out. Another system that was really heavily used for a very long time, the concurrent version system, tried to relax some of these issues around sharing revisions between multiple developers. That's where the concurrent idea came from. And then Subversion, that some of you might have encountered here at Taylor, Also a centralized revision control system. It's a little bit more modern than these others, and as I've noted here, Subversion doesn't suffer from that issue of locking down files such that only one developer can make changes to them at a time. But it's still subject to these other issues that are just part and parcel of using a centralized RCS. Let's turn our attention to distributed revision control, which is the more modern equivalent of what we've been discussing. Here's a simple illustration of what I mean by distributed revision control. Instead of there being kind of one centralized repository where all of the users, in this case Alice and Bob, are committing files and checking out files, a distributed system allows for there to be multiple revision control repositories. And the way I've labeled these says something about how they are supposed to work together. So Alice actually has her working directory, her sandbox still, but in addition to that, she has her own complete copy of the repository for the entire project. The same thing is true for Bob. He has his own sandbox, his own working directory where he's doing his work, and he has his own repository that contains a complete copy of the entire history of his project. So Bob kind of focuses on these two boxes. When Bob wants to check files into his repository, he can go ahead and do that without having any impact at all on Alice's repository and vice versa. If Bob wants to compare his current working directory's contents with previous versions of files that he's working on, he can go ahead and do that directly against his repository. So Alice and Bob can now work sort of independently with the full power of a revision control system kind of at their fingertips without ever clobbering anything that anybody else is doing in other repositories. And that's really the core idea of a distributed revision control system. Everybody has their own local copy of the contents of the entire project, the entire history, all the changes that they've made, all the changes that other people have made, and they can use that locally, conveniently, quickly. Now, of course, that doesn't answer the question of how do we use these revision control systems to collaborate with one another. That was one of the key features of introducing the notion of revision control in the first place. So if Alice has her own separate repo and Bob has his own separate repo, that doesn't really help with collaboration. The difference here in the case of a distributed RCS is that we will now synchronize the repositories periodically. So instead of going directly from Alice's sandbox into a central repository that's also the core part of the development environment that Bob is using, when Alice has collected together a set of changes that she wants to release into the rest of the team, what she can do is allow the other team members to synchronize their repository with Alice's repository. So that synchronization behavior takes place between the repos at an appropriate time when people are ready to sync. There's nothing that forces Alice to check in her local files into her repository at any particular frequency or at any particular interval. She can kind of use it the way that makes the most sense for her workflow. And the same thing is true about Bob. But whenever there's a point in the project's history where Alice or Bob wants to make their changes available to the rest of the team, they can push those things to their repository, and other users from their own repositories can synchronize the changes from another developer with their own, and vice versa. This gives rise to a quite considerable degree of flexibility in terms of the developer's workflow. So in the centralized revision control system, there's just kind of one way to go ahead and do these kinds of projects. In a distributed revision control system, where you might have dozens or hundreds of developers, each of which are going to have their own repositories that can synchronize with one another in any kind of weird pattern that you want, you create an opportunity to structure your development workflow in any way that you see fit. One example of that kind of flexibility is the way that the Linux kernel is developed. So Linux was invented by a guy called Linus Torvalds. You may have heard his name in the past. And he actually still has sort of oversight on the Linux kernel itself. But he can't do all the work associated with that himself. So he has a group of what he calls trusted lieutenants that are responsible for different areas of the source code for the kernel. And they might also have their own trusted sergeants that do more of the grunt work associated with making updates to the kernel. And they structure their repositories in kind of a tree structure. So Linus at the top here, here's Linus. He might have some lieutenants that have their own repositories, and then they work with other developers that have their own repositories, and they've developed a workflow where a person who's maybe making a device driver for a new graphics card or something down here makes the changes in his or her local repo and pushes them up to the lieutenant's repo. And then that person is responsible for kind of integrating code from other people that are reporting up through him or her. And then when the changes are ready to be integrated into the overall kernel, that repository can be synchronized with Linus's master repository for preparing a release. So that's just one example of a pretty elaborate workflow that facilitates the development of a multi-million line code base that's developed by people all across the planet and is one of the most successful software projects in history, facilitated by distributed revision control. So let's take a look at the corresponding analysis here for distributed revision controls. You can see that I've got more pros than cons now. That might be biased, but that's kind of my view of things. The con, and this is basically the flip side of the one pro that came out of our discussion of centralized revision control, is that it's more complex. Right? These pictures of different flows of information between revision control repositories and whatnot can give rise to more complexity, and I think that that's a fair assessment. That said, I think the complexity is worth it, and in most common day-to-day, everyday uses of these things, the complexity kind of gets hidden under the hood. Most of the things that you're going to do fairly commonly are going to just become second nature. They're easy to learn, and so forth. So on the pro side, well, the first thing is, because we have multiple copies of the repository itself, you end up with kind of built-in replication of the source code. In other words, there's no single point of failure like there was with the centralized system. In fact, if we think about these different repositories that we've been talking about, again, they have a complete copy of the entire code base as of the last time that you synchronize that repository with any other changes that were made by different developers. Having that entire history in different repos on different machines, maybe in different parts of the planet, gives you quite a lot of reliability in terms of replicating that code, because no one of these repos is more privileged than any other. They all pretty much stand alone as complete copies of the project. That means that there is no single point of failure anymore. Even if you're a really important central developer in the middle of some more elaborate process, if your hard disk crashes, you can go get a copy of the repository that's going to be as up to date as how frequently other members of your team synchronize with your repo, very, very, very simply. So replication is a good thing. I've already mentioned this notion that there's very flexible workflows. We're going to settle on one particular relatively simple and relatively common workflow for our work in this class, but the idea admits to a lot of other different workflows. Another neat thing is that you get access to your repository whether you're on the network or not. So the scenario that I was mentioning before, where Alice goes to another location and can't access files on the airplane and can't access files unless there's a network connection back to the centralized repo from the location where she's working, that's no longer the case here, because that the distributed repository is traveling with Alice. This entire collection of stuff, her sandbox and her repo, could both be on her laptop. So she has access to the repository while she's on the airplane. If she wants to look at the history of the project or make changes and check them into the repository, she can do that. And then when she lands and gets better internet connectivity, she can then synchronize her repository with other members of her team to share those changes, and vice versa. You have the entire project history right with you. I said before that in the centralized system that you normally, when you did a checkout, you'd only get the latest version of all the files in that project. So on your local machine, you don't have access to the history. You just have the latest and greatest. Whereas in the distributed case, where you have the local copy of the entire repo right with your working sandbox, you have the whole project there. And then the problem of merging that I mentioned before actually becomes quite considerably simplified in the distributed case. Again, that's not so much a function of the fact that it's a distributed revision control system, but the underlying representation of the different versions lends themselves to to making the merge process much less onerous, much easier to do. There's a couple of examples of distributed revision control systems here that you may have heard of. Mercurial, I think, is still being used in the department. And Git, of course, is the kind of the 500-pound gorilla that has taken over the world as the go-to repository of choice. All right, so let's take a look at a specific configuration of revision control using the Git system that I just mentioned, and then another service called GitHub. So here's the picture. We've still got the distributed nature evident here, right? We've got Alice's sandbox and her private repository. We've got Bob's sandbox and his private repository. But there's another repo in view here, and I've called that GitHub. Now let me make sure that it's clear the distinction between Git and GitHub. So Git is actually the software system that manages all of these revisions, that allows you to add a new set of changes to a repository, to fetch changes out of the repository, to compare the contents of the repository, and a ton of other stuff. It's interesting to note that, as I mentioned before, the Linux operating system uses distributed revision control to manage its very complex development cycle. In fact, Linus Torvalds, who invented Linux and still maintains it, is also the person who invented Git. And he did it in order to use it to manage the development of Linux. So two amazing software innovations from that one guy. Very impressive. So Git is a piece of software that you install on your machine and use it to do distributed revision control. GitHub is, as its name suggests, a service that you can sort of use as a hub for your developers to communicate and collaborate using distributed revision control. So GitHub is a website, it's a company, it's a service that hosts repositories. So just in the same way that Alice has a copy of her repository on her laptop and Bob might have a copy of his repository on his desktop, GitHub is a third-party provider that allows you to store copies of your repository with them. Now that has two advantages. One is that because you're storing your repository in a system that's owned and operated by a separate organization, you get further redundancy. You get another backup of your source code that's not on your premises in case you have a fire or a flood or something like that. So it provides some business continuity by allowing you to store your source code elsewhere. Secondly, it's often used to provide a kind of an authoritative copy of your source code. So for example, when someone joins a project and they want to get their initial copy of the repository set up on their local machine, they could conceivably go to Alice or Bob or some other member of the development team, but it's common for the team to use GitHub as a place to store kind of the latest and greatest release of the software or the latest and greatest update of the software, and that often provides a better starting point for a new member of the team to get a copy of all of the software from past development in order to start working on the project itself. Now that kind of seems like we've swung our way back toward a centralized revision control system, right? And in some sense, that's really what's going on here. We're sort of treating this GitHub copy of our repository as the authoritative copy of the code. Again, that's just a choice that has to do with the workflow that we're implementing using Git. There's nothing that's any different about a repository that's stored on GitHub that privileges it in any way over copies of the repository that are stored in a local server in our office or on a laptop that's being used by a developer. They're all of equal standing. This particular configuration that's on this slide illustrates a common way of implementing a workflow that's sort of easy for people to share and that's easy to onboard new developers. So it's become very popular. It's also quite popular in the open source community. So if you're working on an open source project, you're very likely to host it on GitHub or some other Git-flavored revision control system. And when you make a release of your open source code, you're going to push it up to GitHub, and now all the people who are using your code or who are maintaining your code or who are contributing your code to your code can go to GitHub, fetch down the changes from that centralized spot, and continue doing work either using your software or enhancing your software. You don't have to try to coordinate with them directly from, say, your laptop to 100 other laptops for the people who are writing code that's being contributed to your project. One more thing about this slide that I'd like to point out, and we'll drill into this in more detail later, but just the commands and the flow of information that's employed when you're using distributed revision control. So if we think, first of all, about what's going on here with Alice's sandbox, she, of course, can access her local repository and use it however she sees fit in her personal workflow. But again, as with the illustration of centralized revision control, you basically need to do two things. Put your changes into the revision control system and then be able to fetch versions back out, whether that's the latest and greatest or a comparison for some historic purposes or whatever. So to put things into the repository from her sandbox, Alice is going to run a command called commit. That will take the contents of the part of the contents of her sandbox and push it over to her local repository for persistent storage as a new revision. If she wants to look at a different point in the history of the project, she can do the opposite operation, which is called checkout, and that will take a version from the repository and fetch it into Alice's sandbox, making it look exactly like it looked at the point in time when that particular revision was checked in, or when that particular revision was committed. Kind of use those terms synonymously. The same thing is true for Bob. He would be doing commits into his repository, and if he chose to look at a different version of the system, he could do checkouts from that as well. Again, that's just with the local repository on your same machine. When we're ready to share the changes that are stored in our local repository with other members of our team, there's another pair of commands that we use for that. So for example, when Alice is ready to share her changes with another repository, she'd use a command called push. And that's going to basically take the changes in her repository and push them out to this other repository so that it now has the same information in it that Alice's repo had, plus any other information that someone else might have pushed to it previously. In this illustration, I'm showing a push to GitHub, but as I said before, GitHub is just another server that stores a copy of your repository. So Alice could also, if she so chose and if the network connectivity was set up properly, she could push directly to Bob's repo. Would work just the same. Again, no single copy of the repository is privileged above any other. And then let's say that at some later time, Bob had done a push to this centralized repository on GitHub, and Alice wanted to consume those changes. The command that she would use to pull the changes up on GitHub into her local repo is called fetch. So she would now have the changes that Bob had pushed to GitHub available in her local repository. Finally, there is a command that sort of does something that you're going to do very commonly, kind of does two different things. When you're trying to consume changes from someone else on your team, in this kind of model it uses GitHub as the centralized location or the authoritative repository, it's common that you would want to do a fetch to grab stuff from GitHub into your local repo, but then you'd also want to turn around and pull things into your sandbox to merge whatever changes are now available on that GitHub server into your sandbox and merge it together with what you've been working on. So the pull command is a kind of a shortcut for doing those two steps. So it's a fetch that brings things into your local repository, and then a merge step that brings whatever is in the repository into your sandbox, merging it with anything that's already there in your local sandbox that hasn't possibly been pushed out to your local repo or other repos on the project. This is basically the model that we're going to use for the project in this course. We're going to have multiple developers on each team, usually 2, maybe 3, depending on how that works out. But you're going to have your own copy of the repository. You're going to have a centralized place where you're going to share that repo from on GitHub and learn how to use this ecosystem with this very simple but very common model for using Git and GitHub. One of the advantages of that, incidentally, is that I'll be able to help you with your project more easily because I can, here's my little stick figure guy, I can be out here with my own my own copy of the repo and my own sandbox that has your files in it, and I can share it back and forth between what you're working on and my local copy that will allow me to help you debug or enhance your code. And then I can also, when I make changes that I want to share with you, I can put them back out on GitHub, and then you can pull them into your repositories as well. So it turns out to be a really helpful workflow between teachers and students, as well as between members of a project team, both here in school as well as in the workplace.